Hello everyone, welcome to a new video. In this video, we are going to cover the NIOS Senior Secondary Course Computer Science Chapter 2 Binary Logic. This will be there for your public exam, and we are going to see what are the topics included in this one. So the topic is Introduction to Number System. We have already seen this topic in our previous video. Please go and check it out there. What are the number system and how to do the conversion, that is explained there as a detailed video. Do go and check it out there. Now we will have a revision of this one, like Introduction to Number System. So what is a number system? It is to represent the numbers using different symbols that a computer can understand. So usually it understands binary language or binary numbers where 0 and 1s are the values. It can be converted to decimal values, octal value and hexadecimal value. These are the different types of these are the categories of number system where you can convert it to different forms. Okay, when it comes to a decimal number system, the digits used are 0 to 9, so that is in the decimal number system, and its base is 10. So for conversion, you have to multiply with 10 raised to 0, 1 and 10 raised to 1, 10 raised to 2. Multiply each of the digits and then add it. So this example need not be remembered. You can just go to the previous video and check how the values are changed. Okay, the conversion is well explained in that. It's told binary number systems, digits that are being used is 0 and 1. So only two values, 0 and 1. Its base is 2. So whenever the conversion happens, it has to be multiplied by 2 raised to 0, then 2 raised to 1. Each digit will be multiplied by 2 raised to 0, and then comes 2 raised to 1, then comes 2 raised to 2, 2 raised to 3 in that form, and then add all the values. This number format is known as binary number, and the solution of that you will see in the answer. Similarly, octal number base is 8 and the digits used are 0 to 7. For hexadecimal number system, the base is 16. The numbers available are from 0 to 9, and after 10 it will be using the value as A, then for 11 it is B. Similarly, it goes till 15 for F. Base is 16. Okay, these are the basic view given for all the number systems. Here in short you can see here. So when it comes to decimal number, what are the applications? It is used in our basic arithmetic and everything what happens during everyday calculation. Binary for computer logic and circuits. Octal for binaries, another form, another different form you can say. Hexadecimal is for memory addressing, debugging, programming. All these places hexadecimal are basically used. Basically, now the conversions are possible in computer science where decimal to binary conversion is possible, binary to decimal is possible. So it has a method that is explained in your previous video. Now, number system differ by their base and the digits that are used for each type of number system. Okay, so these are the basic number system that is being used. So next is 1's complement. So 1's complement of one binary number is found out by changing its bits, like 0 turns to 1 and 1 turns to 0. Okay, so if any number is given, just convert their zeros and ones and you will get its 1's complement in the solution. And how to calculate is, first write down the number and do the replacement. That's it. We check the example of 1's complement conversion. A number is given as 1010. So this is the binary number given to you. How you will find that 1's complement of this number is, just exchange the digits 0 to 1 and 1 to 0. So you can see here 1's complement will be 0 1 0 1. So like that it comes as the output. Similarly, for the second number you can see here all the numbers are inverted. Next one is how to find 2's complement. So finding 2's complement is adding 1 to your 1's complement. So already if you got 1's complement of a number, add 1 to it. Okay, so in that case you will get the solution. See the example here, 1010 is your number. So 1's complement of this will be 0101. Digits are inverted. Okay, then add 1 to it to make it 2's complement. So when you add 1 to this one, consider you are adding 1 to this this number. So it will be 1 and 1 will give you 10. Okay, according to your binary calculation, the carry will be there. So that 0 is here and that carry is here. So 1 and 0, it will give you 1. Again 1 is there and this 0 is there. Similarly, write it down. So you get a 2's complement. So this is the solution of your 2's complement. Okay. Similarly, check your second example and solution as well. Next one is character coding systems. So computers store everything as numbers, usually zeros and ones, and you have to represent these numbers, letters, scripts, everything. So for that we are using this character encoding system. Let's see what it is. First coding system you can say is character coding system is ASCII, or you can say ASCII. Okay, so till now we were seeing number conversion and number coding, how it is done. Now we are also seeing a character. So here you can see it's you can see the abbreviation for ASCII is American Standard Code for Information Interchange. Okay, basic details are given here. It is introduced in the year 1963, and you can see here its size 7 bits and later extended to 8 bits. These are the things covered in this one. So English letter A to Z is covered here, from lowercase and uppercase, both are there. These digits comes under this, and punctuation symbols are also there. New line, tab, everything is included. Okay, it supports English. Other languages you cannot use with this ASCII system. Okay, let's see what are next. So you see the example as A value, or the uppercase A has the value as 65 in decimal, and you can see here how it is to be converted to your binary value. So this conversion is there in your previous video of binary logic. Okay, for lowercase it is 97. So each character has different values. Next one is ISCII, Indian Script Code for Information Interchange. So here it is used for your Indian languages, like it is introduced by Government of India. Okay, like it uses the languages like Marathi, Bengali, Tamil, Telugu, Kannada, Malayalam, Punjabi, Oriya, Hindi. All these languages you can see here on the screen. This are included in for your ISCII. Okay, these languages codes comes inside this. Now you can see example as this code represent A in your Devanagari. Okay, so but the same code can mean equivalent vowels in other Indian scripts. So different languages have different codes which is being given by ISCII. It is Unicode. It supports all the world languages and symbols, and usually emojis, mathematical symbols, scripts, and other things are included in this Unicode. The limitations of your ASCII and ISCII limitations are being solved by your Unicode, and how it is to be used. For that letter uppercase A, you are using an Unicode and then adding another value. So its code is different. Then when you see a smiley, its code is something else. Okay, for A in Devanagari it is something else. So like this, these are the character encoding system. You get the comparison between all the three in one screen. So if you enjoyed this content and it was useful for NIOS students and anybody else who is learning binary logic, don't forget to give it a like. Do share your comment in the comment section, and also share this with your friends who are also preparing for this exam. Thank you for watching.